Hello, everyone. Welcome to our second OPEA Demopalooza. Seeing some Gen AI RAG workflows in action. We have a delightful lineup for you today, and I have a delightful mocha here. I hope you have your favorite drink with you. I'll be breaking out some snacks later. So we are going to start with a quick update of OPEA and what's been happening lately. So some of you may be more aware of that than others. So we'll keep that relatively brief, maybe even open up for different questions, comments, hear about your experiences with the software. Then we are going to move on to a cool demo of OPEA on the IBM Cloud from my colleague Pramod, which will be really cool. After that, our next session will be migrating from an OpenAI RAG workflow to an OPEA RAG workflow. And I saw an early version of that demo, or sort of like the reasoning behind it. And that was really, really cool. So I'm excited to see that. Both of those, I would encourage you to ask questions because those are some real technical folks there. And then the last one, I am going to talk about GraphRag. And I have a couple of demos, one from Neo4j and one from my colleagues here at Intel. And so we'll take a look at those. And then I'm hoping my friend and colleague Malini is on here so she can answer questions that might come up in LinkedIn or YouTube. But with that, I am going to transition over to my slides to start things up. So just give me 1 second to do this. Present. Share screen. Okay, sharing is easiest with that, but of course I don't have that. Let's see. Okay, I think this is what we're going for. And let's see, can I get a confirmation that my, oh, I see it. Okay, you don't need to confirm. So let me make it big. Oh, now I'm myself on something else. One moment. Okay, slideshow it is. All right, here we go. So it's getting really exciting in the world of OPEA. I hope it's been exciting for you. So just a super quick recap. Gen AI is everywhere. There's lots of cool business and tech opportunities, but it's complicated, right? And so hopefully this suite of framework, a way to think through things, blueprints, and a growing assessment system helps you to think through, business cases where Gen AI would actually be complementary or improve your business outcomes, not just sort of like attack and add-on. Will help you through figure out how to help your team develop rapidly these projects, and then get them out into production and deploy them and make sure that they are successful. And as you know, things are moving really fast. And so things are moving fast with this project, and we have lots of new things to share with you. So starting with some big news, AMD joined a couple of months ago, which was really great news. We're super excited to have another hardware provider on the project, and they are contributing to the CI/CD for validation. So that's something that's ongoing. I was looking at the pull requests. I think some may be merged, some may be open. So that's something that's happening. We've had some really, really great collaboration with the AMD team. And if you ever want to see any insights into that sort of stuff, you can join our working groups, and a lot of conversation happens at the technical steering committee. All of those things are open if you ever want to drop in and see what's going on with this particular project or how open source works. Another tack that we're looking at is partnering up and getting OPEA solutions on the different cloud marketplaces. So I believe we're starting with AWS, but the goal is to have them on multiple cloud service providers. Basically, wherever developers are, we want to make sure that OPEA is something that can be used with other tools that you're using, which is great. Amazon is contributing integration with Bedrock, which is really cool, and OpenSearch. And I wanted to highlight Infosys as well. They're scale testing OPEA, as it says here, using Elastic. So they've done a lot of great stuff. And they were involved in our hackathon as well. And then you'll actually see a demo from Neo4j using their GraphRag tool set. And OrangoDB is working on GraphRag stuff as well as Intel. So lots of GraphRag stuff happening, which I learned a lot about over the last couple of weeks and is really fascinating. So we'll definitely be talking more about that. And that's something that is a big addition to the GenAI blueprints that we have here. So we started out with, I don't know, a few, but now we have 22 end-to-end examples. By far, chat Q&A is what everyone is looking for. So that's one that we're making sure that's built out, has different choices in terms of the different tools that you can use for the different microservices. But we're definitely adding more. You're going to see there's going to be more to come with the 1.1 release, which is a slide that we have coming up. And like I said, so you can see GraphRag right in the middle there. So we've got lots of GraphRag stuff there. So that's cool. So 1.1 release, my understanding is the code was frozen Monday, but the release isn't until next week. So keep your eyes peeled. I'll put it in the newsletter if you're a part of that. If not, sign up at opea.dev. So even more new examples, AI agents. So you're going to see lots of agentic stuff coming through. GenAI Studio, which I believe is like a no-code front end for OPEA. Chat Q&A with a knowledge graph, so super powered with that for more global questions. Different components, mentioned a couple of these, the Neo4j knowledge graph, OpenSearch, VectorDB, which is great, and a refined service API. The infrastructure is getting more and more refined and robust. Lots more Helm charts. All I hear about is Helm charts. And then apparently we'll have some front-end metrics, which is cool. As I mentioned, evaluation is something that's being more and more built out. We're having this new long context, but I know there's lots in the pipeline in terms of evaluation. So keep an eye out for that. And just new model compatibility. I'm sure, like I said, I mean, things move so fast. This will continue to update and add models. And so you can see there's Llama 3.2. And I don't know if you say Gwen or Quen, but that's a cool one. And then new hardware support for Intel Arc and working towards AMD support. So very exciting stuff. I forget. No, I do put that later. So I'm not going to say what I was going to say. So I thought this was fun. Just kind of a look at the numbers. Now, remember, this was something that launched on mid-April. And I'm really proud of the work that everyone on the OPEA team has done. So just to go through them. So GitHub, I remember when GitHub had 12 followers. So now we have 612, which is awesome. People seem to be really gravitating towards the GenAI examples repo, which is great. And then that uses components from the GenAI comps repo. So if you want to know how to put something together and look at the different microservices, the example repo is where you go. OPEA.dev, which is the best place to start. And then you can go to our wiki from there. There's blog posts. There's technical documentation. There's event updates, all that sort of good stuff. Generally, OPEA.dev is a good place to start. And we've had 25,000 visits. And so that's been really growing. I didn't add any graphs here, but I noticed in the past month it has sort of, up and to the right, which is really cool. Virtual events, which if you've been here before, those have been something that I've been involved with. And so we've tried a few different things. The demo seems to be something that people really like to see, which, and why not? You want to see how something works before you decide to use it. But we've had a lot of people register and either check out live or post live the goodness that people have brought here, and that's been really great. And we're currently setting up what we're going to do for 2025. And then we have 48 partners, and that is growing at about like one a week, 1 to 2 a week. But that's great, and I think I put them all here, and you can see here, as I've said before, they're really all over the place, big, small, ISVs, OSVs, all different corners of the technology world that touch upon, um, generative AI, which is what's so amazing about open source. And so just imagine all of these great minds from these companies working together to figure out how best to enable developers and change and innovation, which is great. So what's really cool, and I'll put this link, or we'll have someone put this link somewhere, is that we actually have an appliance out there now with Dell and Intel and OPEA. And so that's actually a live link, which obviously you can't click right now. But like I said, we'll throw it in the comments. But it's really cool to see something that is powered by OPEA out in the world. And I will say there's a very, like a full handful of other projects that are on their way. And that has been very exciting and very gratifying after all of the work that many, many, many people have been doing. So this is just a sort of a glance at what we're thinking about in terms of the roadmap. Still need to talk to a bunch of people, but I wanted to give those that are, active and interested sort of a glimpse at least into the next couple months. Looking at integration into some of your favorite LangChain, Haystack, and Llama Index. As I mentioned, looking into that, getting OPEA on different marketplaces, looking at AWS first and foremost. The OPEA GenAI Studio is something we're looking for. And then we're always just looking at upgrades and stabilizations. And then our hope in 2025, and obviously put a pin in this, right? Because things move really fast, is that we want to have really sort of like a 2-month .x release schedule, and sort of going back and forth between, refining and performance and new features. And so, like I said, put a pin in it. This could change, but I did want to give a little glimpse and show that this team is very active and is very much looking forward, expanding things, grow, it's a great project to be a part of. And hopefully that's something that you can make time for or use in 2025. And so, as always, call to action, looking for people to participate in working groups. That is something we desperately need people to do. And you can check that out on opea.com. Always looking for more enterprise use cases with any new technology. As I said before, people need guidance. You know what I mean? They need to know, how can this help, right? And then they start to look into what that could actually do. And you don't want to have that sort of be off to the side, like I said, being like adding on like a little, like, here's a little Gen AI. You really want to figure out how it can impact your business. So that's great to share that. Obviously looking for code contributions, pull requests, stuff like that. Docs, we definitely need help with. If you're in open source, that's an area that is constantly in need of help on all different projects, but definitely looking for people to contribute. Also provide feedback. Also, like, what's working, what isn't working. I know we've been working hard on developer onboarding and making sure that that is something that we're making easier and easier. A team is working really hard on that. And then if you can just spread the word, let us know if you're using it. Let other people know if you're using it. But that would be great. And we'd love to see people, in 2025 as well, giving sessions on it, showing how, it's really making a difference in their world. So I think that's it for the actual slides. So let me get out of this and let me unshare my screen. Okay. You might have gotten a glimpse of the background there for a second. Okay. So I wanted to just take one moment to see if there were any questions, and that's going to take a minute because I need to go and look at that. And I'm just looking to see if there are any comments on LinkedIn or YouTube. Let's see. Hold on. Okay. Oh, thank you for adding those things. Okay. I don't see anything. So my next question. So I'll hold 1 second to see if there's any questions at all. Anybody wants to write in? Okay. All right. So let me see. Do we have oh, Pramod is here. Thanks for joining. Right on time, Pramod. Okay, so like I said, I'll have Pramod introduce himself, but he is a colleague here at Intel. He does a lot of great work. Hey there. And he's worked on this demo, which I'm very excited to see in action. I haven't seen this in action, so it'll be a first for me as well. Let me see. Wait a minute. There's comments. Oh, no, those are the same comments. Okay. So anyways, without further ado, I'm going to let you take over and share. But looking forward to it. I'll talk to you on the other side.
Oh, yeah, absolutely. Thanks so much for the introduction, Rachel. Hey, everyone. I am Pramod. I am an AI Software Solutions Engineer at Intel. And what I have for you today is a presentation on OPEA on the IBM Cloud. So in the presentation, we will see how you can use the workflows in OPEA and get it set up on IBM Cloud. So for this, I'm going to have to share my screen for a presentation. There we go. And yep, I hope that is coming through. Okay, here we are. So, yep, like I said, open platform for enterprise AI, OPEA, and the IBM Cloud. But before we dive in deeper, let me just quickly outline the agenda so you can get a clear idea of what to expect. We'll start with a brief introduction to OPEA. And after that, I will cover the prerequisites. So this includes how to set up a virtual server on IBM Cloud, as I mentioned, for you to successfully deploy and interact with the chat Q&A application. We'll see what the chat Q&A application is. Just to foreshadow, it's a RAG pipeline that you can set up very quickly within minutes. So after that, we will move on to deploying this chat Q&A application. I'll show you step by step how you can do it, and we can access it for real-time question answering and contextual data retrieval. Following the deployment, like Rachel mentioned, there's a demo. So you'll see how the chat Q&A system functions in real time. So with that, let's begin with a very quick introduction to the OPEA project. So OPEA stands for Open Platform for Enterprise AI. It is part of the Linux Foundation. The OPEA project, it has three core components, as you can see here. The first one on the left, we have the framework of composable building blocks. So this framework provides the foundational tools you need for generative AI solutions, things like LLMs, data stores, prompt engines, and these are the core elements that you would use to construct robust AI systems that are tailored to specific use cases. In the middle, you have the blueprints. So these are end-to-end workflows. So these blueprints are predefined. For example, the RAG pipeline that we will see in the demo later. And finally, the assessment for grading GenAI systems. So this component focuses on evaluation. So it provides tools to assess GenAI systems across a range of criteria. So that includes performance, feature richness, trustworthiness, and together all of these form a comprehensive ecosystem for both constructing and evaluating GenAI solutions. So if you look at the core architecture of OPEA, it's built upon these three key components. You have the microservices, the mega services, and a gateway. So microservices, well, each one can be considered as a building block. Each microservice is designed to carry out a specific function. So examples like retriever, re-ranking, the LLM itself. So all of these are wrapped inside microservices. So this way, you have services that are flexible, scalable, and easy to maintain for enterprises. They're also containerized, so you can deploy them seamlessly in cloud native environments. And so all in all, it is very ideal for enterprise AI applications. And then you have the mega service. So these are constructed by combining one or more microservices into an integrated solution. So unlike a single microservice that focuses on specific tasks, mega service handles more comprehensive business logic by tying all of the microservices together. So by using these mega services, OPEA can offer ready-made workflows and complete solutions for you to try. And finally, we have the gateway. So it's represented in red here. So gateway is the entry point where the incoming requests first land. The gateway then routes these requests to the relevant microservice within the mega service. So this is how the OPEA architecture is set up. Now, before we get into the demo itself, let's get a quick background on RAG, and then I will show you the uh, architecture diagram on OPEA for RAG, and then we can move on to the demo. So in this slide, let's look at what RAG is. That is retrieval augmented generation. So it is a pipeline that is used in chat Q&A. So this pipeline is all about enhancing LLM responses. So you do this by incorporating information retrieval capabilities. So this way you make the generated answers more accurate and context aware. So let's break down these components. So you start off with data preparation, the raw data. So this would be your document store from which you want the LLMs to answer from. So this data is cleaned and organized and chunked into manageable pieces for further processing. Then you have the embedding. So what the embedding does is so all of the retrieved data, it uh, converts it into vector representations and puts it in a database for the LLM to, for the retriever to pick in the next stage. And when you do the query processing, the system searches in this database to retrieve the most relevant data chunks. So this way you are grounding the responses in factual context. Finally, the LLM itself, the retrieved data is then along with the question and the context is passed into the LLM. So this way you get more reliable answers and answers that are grounded in factual information. So this is how a RAG pipeline works. So in the chat Q&A itself, this is what the architecture looks like. So in the previous slide, we discussed the RAG pipeline, right? So In this slide, we're looking at how the processes that I spoke about, how they come together in a more architectural form. Uh, so here it's composed of, again, microservices, and each one responsible for a distinct functionality. Much like we discussed before, there are embedding, retrieval, re-ranker, and LLM microservices, and together they form what we call the chat Q&A microservice, as you can see here. Starting from the left, the system begins with the user interface where data is ingested or a query is submitted. This user input is handled by the chat Q&A gateway, and this forms an entry point into the architecture. Once the input reaches the mega service, it goes through the embedding microservice where the data is transformed into vector representations, and then the retrieval microservice, which uses these embeddings to pick from the database the most relevant information, and then you re-rank it if needed to just refine all of the documents that have been picked up before finally it is sent to the LLM microservice, and that's how you get a response that is grounded in factual context. So now, if we were to set such a pipeline using OPEA on the IBM cloud, let's see what are the steps that you can follow. I'm going to get out of the presentation mode here so that I can switch to the browser screen. And yeah, let's see how we can set up an instance and also set up this pipeline that I spoke about. So you can see here there are about 10 or 11 steps. So you first start off by going into the IBM cloud. So if you don't have an account, definitely make one, and then you can click on. So once you get here, you can click on Create Resource and Compute, and then you can go to Virtual Server for VPC. Right. So here, this is pretty standard stuff. You can select the region, and then you can name it. I'm just going to say OPEA Demo, let's say, or 2, because that's already an existing name. Right. So the next important bit is the image and the profile. So as you can see here, we recommend selecting Ubuntu 24.04, and the profile. The recommended setup is using an instance such as BX3D 16x80 or above. So the 3 here signifies that these processors use Intel 4th Gen Xeon Scalable processors, and with that you get the AMX instruction set support, which think of it as an AI accelerator. So any instance that you see in the 3 series or above would be great. So then you would select such an instance. So you see here BX3D. So any one of these instances would be great. And then you set the SSH keys, and let me make this larger for a second. Right, so let's actually look at one such instance. Yeah, here's BX3D 16x80. Anything above this should be fine. BX3D. And then once all of this is set up, you can just click on Create Virtual Server here. So in the interest of time, I've already set up a server. So I'm just going to go to the one that I set up so that I can then continue showing you the next steps. So we go to compute. Yep, there's the one instance that I created. All right, so once you have the instance created, you just have to do one more thing before you can log into the instance, and that is creating and attaching a floating IP. So the way you do that is you can go into networking, And when you click actions here, you can select this edit floating IPs option. And once you do that, so here I'm just going to unbind it for a second because I've already attached the floating IP to my instance. But this is what you would expect to see. There are no floating IPs. So then you could click on attach, and you could use the floating. So in my case, I already have this floating IP. If you didn't, then you could just reserve a new one. It's pretty simple. So I'm going to use the floating IP that I already have. There we go. We attach it. And yeah, that's it. So once you've attached it, you have the instance. It's ready to be logged in. So let's go to my terminal. Right. So you have the floating IP set up. Um, oh, I forgot about this, but my bad. So just before you log in, there's another thing that you need to do, which is you have to go into the security groups and you have to enable inbound traffic for port 80, because this is how the traffic will flow into the chat Q&A RAG application that you will be setting up. So to do that, you have to go into network settings on the left. So you go into the network settings and then you click on security groups. So this is the one that belongs to the instance that I have. And then you can go into rules, and then you can create a rule and then add 80 here. So that way, all the traffic that is going into this port is allowed. So I already have done that, as you can see here. Port 80 is open. And yep, the final step is to SSH into the instance using the floating IP. Let's do that next. So I'm going to go into compute. My instances. Right, here's the floating IP. So all you would have to do is use your SSH key that you created. The username would be Ubuntu by default, and then the floating IP. And yeah, we've logged into the instance. Now that we've logged into the instance, the next bit is about launching the pipeline itself and looking at the demo to see how it's working for us. So here, uh, there are a few steps here that I have already done in the interest of time. So I installed Docker. So since it's a fresh virtual machine, it didn't have Docker. So I did that. Another thing you're supposed to do is you're supposed to configure Docker to run as a non-root user. So the link is here in this slide. So essentially, you go into this website and follow the steps here. So this being the main one. You add your user into the Docker group, and once you do that, to test, you can just run Docker run hello world, and it should run without sudo. So that's how you test it. In this case, we can see it is running without sudo. And then let's see what's next. Right, so you clone the repo, GenAI examples. That's where the chat Q&A application lives. So once you've cloned it, you can go into this folder called chat Q&A, and there are a few configuration settings that you have to take care of. So you set the host IP to localhost, and then this is important. So you have to export your Hugging Face hub token. In my case, I'm just going to do it through an environment variable that is part of a bash script. But you can just export it right here. So I just have one here. So I did that. Next, we can go into the Xeon folder here, since we are running this demo on a Xeon. And here's another script that lets you set a few variables such as the model, the LLM model, the embedding model. Let me show you. So this is what that script did. So you set the embedding model, the re-ranker, the LLM. So you set all of these here. Let me get out of that. And once you do that, we are ready to set up the pipeline. So we use Docker Compose to set up the pipeline. So what this does is it launches all of the microservices along with the mega service and also the gateway that we saw. So once all of these services are set up, you can connect to this pipeline through the gateway and get a response. So now you have several options here. I've mentioned TGI and VLLM. So I'm just going to go with the VLLM option. So VLLM is a serving engine which forms the LLM, the backend LLM service. So it's a Docker. This is the Docker Compose command. So once you do that, in my case, all the images have been pulled already. And the images were running. So in this case, it's pretty quick to set up the pipeline. But if you're setting it up for the first time, it will take a few minutes for all the images to get pulled. So once you do this, you can see that these are all the microservices that belong to Chat Q&A. You can see how they're currently running. You can do Docker PS to see all the images that are, all the containers that are up. And then the LLM backend service is something that takes slightly more time to get set up compared to the rest. So I've added this command here to check that the service is up. So you can do a Docker logs VLLM service, and then you can just grab this string startup complete, and you should see something like this, that the startup is complete, and then the server is running on this address. So once you have that, you can be sure that the backend service is running. As you can see here, the backend service is running. Right. So once you've done that, the final step is to get the public facing IP of the instance that you have. That is pretty easy to do. You can just do a curl of ifconfig.me, and that will tell you what the public facing IP is. And I take that IP, I go to my browser, and remember the UI is being served at port 80 through the Nginx ingress. So if I go here, now the Chat Q&A UI is set up. So this is where you upload the documents. So this would form the ground truth for the model. I can show you an example. So let me ask this interface, what is OPEA? As you can see, it says that OPEA is Organization of Pension Benefit Funds Employees Association. Well, it might be in a different context, but in our context, we know what OPEA is, Open Platform for Enterprise AI. So I have a document here that captures what OPEA is. So I'm going to upload that. And then I'm going to ask this Chat Q&A application again, what is OPEA? And this time you should see the corrected answer. So this is grounded in the information that you provided. So yeah, so that's how you set up the pipeline. And before I end the presentation, I just want to take you through this folder from which I launched the pipeline from. You can see there are several compose files. So the one I chose was compose VLLM. So just to show you what it looks like. So it has all the microservices set up along with the mega service, and all the configurations exist in this compose file. One additional thing that I did was add this D type to bfloat 16. So generally models run in a floating point 32 data type, but if you add the D type as bfloat 16, firstly, the operations, all of the operations happen in bfloat 16 with 16 bits instead of 32 bits. At the same time, the 4th gen Xeon scalable processors, that is the recommended instances, they have support for for bfloat 16, and they accelerate these operations. So you should definitely see a speed up after using this data type. So yeah, that was the presentation. I'm just gonna stop the screen share now.
That was I have just a couple of questions, and we'll talk for a minute to see if anybody has any questions. But so my first question to you was, it seems like you found this pretty easy, but like, was it? How was it like putting this together? How did you find it? Was it difficult? I mean, you've made it easier for everyone else.
Well, yeah. What I would say is because of the Docker Compose command, right, that OPEA provides, uh, that abstracts away a lot of the network configurations and the images and the models that you need to set up such a pipeline, because it is definitely a very complex pipeline, and there are a lot of moving parts underneath, right? But so OPEA, what it does is it gives you a baseline configuration which is really easy to set up.
Okay.
Uh, Compared to if you were to go set up everything individually by yourself one by one. We have to imagine that this pipeline that was set up in this demo was pretty complex if you were to do it by yourself, piece by piece. So since a baseline configuration is set up and it even works on a CPU, you don't even need a GPU. Um, so that way, once you've set up the baseline configuration, then you can tinker around and change the model, the embedder, and you can tune it to your application. So that's why I would say that it's pretty neat.
And had you worked with the IBM Cloud before? I'm curious how it compares to other cloud services.
um, I think when it comes to cloud services, the only minute differences might be in the way that you set up the instances. Ultimately, it's the same thing that you do across different cloud providers, but it's just small things that are different
Sure.
in their instructions. But once you get past that stage, everything else again becomes common across all of the cloud providers.
And have we put this into the repo so that people can follow it along and stuff?
Oh, right. So let me.
If we haven't, I'll be reaching out to you after so that we can put that together.
We actually have. Let me just share my screen again.
Sure.
I completely forgot to present this one final slide.
Oh well. Oh yeah, that's right. I remember you said.
It's my bad. Let me go back in there. Yep, this is the one. So all of the steps that I showed, I don't know if I can share, or maybe actually you can just put this in the chat box for the audience.
Yep.
So yeah, so all of the steps that I shared and more details are in this page. This is the getting started page. You have all of the cloud providers as you see here, and I think these links could be very useful as a call to action from where, after watching this presentation, you can probably just explore these links and go further.
Yeah, I know a lot of people worked hard, including yourself, on that. What are you going to work on something next with OPEA? I'm curious.
Let me get back here. Yeah. So next, so OPEA 1.1 releases on 29th. So a lot of new features. So Yeah, I'm particularly excited to see how the multimodal models become a part of
Mm.
OPEA, and then you can start using those models in the pipeline. I think that could be a game changer. Yeah.
We have a question that I think I know the answer to, but I hope you do. From Hatham. Thank you, Hatham. Have you tried it on OpenShift or any other Kubernetes flavors?
Yeah, absolutely. I have tried it on Kubernetes. So uh, so the repo that is part of the links that I think Rachel will post, it
Yeah.
has the instructions to run with Kubernetes as well, both Red Hat OpenShift and vanilla Kubernetes. Again, it's all of the instructions are very similar. It's very easy to set up, just as you did with the just as we did with the Docker Compose now in the demo. All of the YAML files and the Helm charts are available to set up this pipeline and more using Kubernetes.
Awesome. All right. Well, I thank you for all the time you put into that. I know there's a lot that goes into a 30-minute presentation. So appreciated. And I'll follow up with you in a couple of days. But thank you.
Of
Thank you so
course. Thank you. This was great. Thank you so
much.
much.
Thanks. Okay, we are going to move on to our next demo, which is really cool because I think that one was really about like getting started, setting something up, grounding you. This one's about like you have something, right? You have something in the works already, and maybe it's working, maybe it isn't working for you. What's next, right? So it's a different perspective, and I really like this, and was excited when it was brought to my attention. So Joshua and Chris, also Intel colleagues, are going to be joining us. Here they are. And they are going to be talking to us about work they've been doing around, hey there, hello, migrating from an open AI RAG workflow to an OPEA workflow, my favorite kind. And I'll just let you guys go to it, and I'll talk to you on the other side.
Sounds good. Cool. I can go ahead and start presenting. Sorry about that. Can everyone see the presentation?
Yep, the chat looks like it says yes.
Okay, sounds good. All right. Well, hi everyone. I am Chris Asyong, and I am an AI solutions architect at Intel. And with me, we also have Josh Segovia, who is also an AI solutions architect at Intel. And so, first of all, I would like to thank you for joining us today for this session, where Josh and I will be presenting about deploying OPEA, or Open Platform for Enterprise AI, to augment your existing solutions. And so before we deep dive into the details of this deployment, I want to first of all, look at Enterprise AI and GenAI from a broader perspective. And so today, enterprises have reached an AI inflection point, a pivotal moment in their AI adoption journey, as it is characterized by the swift adoption trends and the transformative impact of GenAI, which is reshaping industries and enterprises. And in fact, by 2026, 80% of enterprises are expected to leverage generative AI in their workflows, according to Gartner's 2023 research. And similarly, edge computing is becoming increasingly integrated with machine learning. And by 2026, at least 50% of edge deployments will involve machine learning capabilities and enabling real-time decision-making closer to the data source. And this growth is also reflected in enterprise investment. Spending on GenAI is forecasted to increase dramatically from $40 billion in 2024 to around $151 billion by 2027. And this data, sourced from an IDC survey, highlights the willingness to adopt AI and GenAI. However, enterprises are struggling to bring their AI workloads and solutions into production. Throughout our work at Intel, many of Josh and I's customers have been challenged throughout the development and deployment of their GenAI solutions, whether it was the process of identifying main components of GenAI or RAG pipeline, questioning the interoperability of those components, how they're stitched together, or whether they are replaceable, whether they should be opened or closed, or how they should scale or validate their solutions. And as we can see from Gartner's survey that investigates Gartner's survey that investigates the main barriers that enterprises have in their adoption of AI. And if I were to highlight a few primary reasons, enterprises are struggling with the technical implementation, which reflects the complexity of deploying generative AI systems from integrating models with their existing infrastructure to scaling them for production. And then there is the cost of running GenAI initiatives that is driven by the high expenses of training and maintaining models, including cloud usage, specialized hardware, and skilled talent. And another major barrier that relates to governance and privacy, where there are concerns about data privacy and ethical issues such as bias and discrimination. And so, in addition to the previous barriers, from our interactions with our customers and partners, we have determined that these concerns are still very much prevalent within already existing GenAI workflows. On the technical implementation front, enterprises have, for example, been hindered by, again, this complexity of integrating new capabilities, functionalities, and frameworks within their existing AI solutions. Furthermore, enterprises have been finding it constraining being locked into closed ecosystems and having to depend on only select proprietary technologies. When it concerns costs, many enterprises are becoming increasingly aware of the costs associated to fine-tuning and training, and are starting to look at alternatives such as using small language models versus large language models, or using closed versus open ecosystems. And of course, when it comes to privacy, enterprises are concerned about data privacy, transparency, bias, and fairness issues, especially when it comes to the black box of closed ecosystems such as OpenAI. And so with all these barriers and concerns in mind, this is where OPEA fits in. The Open Platform for Enterprise AI, OPEA, is an open platform of composable building blocks for state-of-the-art generative AI systems. At its core, OPEA is about simplifying the development, production, and adoption of GenAI for enterprises. And by providing a more modular ecosystem of components like large language models, data stores, RAG, or prompt engines, enterprises are no longer constrained by monolithic or rigid frameworks. Instead, they can consume individual components or construct entire workflows from OPEA with remarkable ease. And whether enterprises are working in the cloud, on-premise, or at the edge, OPEA's deployment versatility and flexible architecture allows you to run your applications and workloads everywhere. Additionally, what makes OPEA transformative is its commitment to an open ecosystem. Traditional AI platforms often lock users into specific vendor ecosystems or computational models. And OPEA allows you to overcome those limitations, providing a vendor-neutral toolkit that empowers organizations to build precisely the AI solutions they need. And so the future of generative AI isn't about a one-size-fits-all solution. It's about adaptability, customization, and providing the right tools to turn technological visions into reality. And OPEA, with the help of its growing list of partners, is doing just that. I will now turn it to Josh, who will deep dive into a specific example of how OPEA can help in augmenting your already existing solutions.
Great, thank you. Okay, so let's talk a little bit about this particular customer that Chris and I helped transform their prior workflow, which incorporated closed source models with an OPEA instance that they stood up themselves with an open source model. And so the customer requirements were that they wanted to be CPU only. They wanted to self-host the large language model, and they wanted, of course, similar outputs to what they were currently having with their solution, which involved API calls to GPT-4's embedding model and, to OpenAI's embedding model and to OpenAI GPT-4. And the key here was that they needed it to be a drop-in replacement for their current workflow. So they didn't want to spend an egregious amount of time standing everything up that they've already built. They just wanted to augment specific portions of their workflow and make it open source and increasingly make it agile so that way in the future, as new models came out, they could quickly swap out particular models to provide the best answers for their customers. And so going to the next slide, their current solution, we pinpointed two key areas where we were going to make some change. So in terms of the embedding model, it was currently OpenAI. We could stand up an OPEA text embedding inference endpoint that could replace that embedding model. Second was the final inference call. So the solution is a RAG-based implementation. And so that contextualized prompt that they built using their prompt templates, that prompt was fed to OpenAI GPT-4 model. And we wanted to augment that solution by creating a VLM OPEA OpenVINO endpoint that made use of an OpenVINO intermediate representation quantized model. And so if we go to the next page, the modifications here are that instead of OpenAI, we went to OPEA endpoints for these two. And what's great, and I want to make a point of this, is that for that LLM endpoint, our OPEA VLM instance that we stood up for them is actually chat completions compatible. So we're using a lot of the same code that they used before, making really minimal changes to that entire code base in order to fit the solution in. So it really acted as a drop-in replacement for their particular solution. And so if we go to the next slide, we can actually take a closer look at exactly what changes that we made, right? So we made the switch from OpenAI Text Embedding 3 to BGE Large 1.5, OpenAI GPT-4 to Mistral 7B Instruct. Now, they also had some helper functions that did some summarization for them. Those helper functions also made calls to OpenAI's GPT-4 model. We also replaced those helper functions with Mistral Instruct. So things like summarizing lengthy queries that maybe surpass the context window of certain model, large context windows. We replaced those helper functions with, again, a VLM, OpenVINO, OPEA-based endpoint that held Mistral Instruct as that primary model. And so if we go to the next page, we can start to take a closer look at exactly how we changed it. So for the inference call, everything else stayed the same. Their existing retrieval mechanism stayed completely the same. The algorithm they used on the back end to compare the embedding question and the embeddings done for their vector database, it stayed exactly the same. We made no changes to that at all. That call to GPT-4, instead of passing in that contextualized prompt to OpenAI's model, we instead pointed it towards our OPEA endpoint, which again had OpenVINO Mistral 7b instruct. And what's great, actually, if others in the call are trying to implement this as well, is that if you do an OPEA VLM OpenVINO endpoint, it'll automatically quantize the model for you into intermediate representation format. Or OpenVINO has done great diligent work on getting intermediate representation models already up on their Hugging Face page. So you can actually just pull that exact model, and in the quantization process doesn't need to take place. But otherwise, it's an extremely seamless process to get that endpoint stood up. Next is embeddings, right? So the customer had existing functions and existing workflows that embedded their HTML and PDF documentation they used to populate their vector database. We changed none of that. So all of that stayed the same. And I'll go into this later. The change we actually had to make when we made the embedding model was to re-vectorize their data, because the size of the vector that's produced from the embedding model will be slightly different than what OpenAI has. But otherwise, once those vectors were repopulated into the vector database, we utilized all of the same code that they had before, the same retrieval mechanism. So again, reusing as much of their code as possible so that their changes don't have to be so extensive, and they can seamlessly deploy this without having a lengthy process of recompiling or recreating everything from scratch. And then the helper functions, we did those changes to the helper functions. There were some prompt templates that we had to modify a little bit to get the exact outputs that their previous helper functions made. But otherwise, again, another fairly seamless change that required very minimal change on their part. And then if we go into the next page, this is kind of what it looks like, right? So we pulled Mistral 7b instruct, the OpenVINO intermediate representation straight from Hugging Face. And it's a little bit blurry here, but we're just showing off a little bit of code on how it works. And chat completions works almost the same way. One of the differences here is that the OpenAI key here will be empty because we're not actually using their service. We're essentially just doing chat client completions.create, and then we're passing in all of our payload in payload in those parameters, and then we're calling it the same way, returning the chat completions object and extracting the text from it just the same way you would do with your previous workflow. So again, reiterating here, really, really seamless change for the customer. And then if we go to the next page where it was TEI, so this one is somewhat slightly different. If you were doing it with, if you were doing it for the text embedding model and OpenAI, you'll have a slightly different object here where you'll go into a dictionary value to sort of parse the encoding, this vector here, this encoding vector. Whereas if you use TEI, it's actually going to return an array that contains vectors within that object. So it's just a slightly different way of accessing it, but essentially it's the same. Once you retrieve that vector, you use your existing workflow your existing RAG workflow to contextualize your prompt. So the retrieval mechanism stays the same. So again, a fairly seamless integration for the customer. And then, okay, so what did we learn here? Doing this with the customer, Chris and I, we quickly learned that when it comes to retrieval augmented generation, smaller models can match the output of these large 100 billion to trillion parameter models, especially when your particular workflow requires requires a lot of information to come from the context from your vector database. having a smaller model that understands the instructions rather than one that's creating new information from the database that you pass in. Having a smaller model can really match that output, and then you don't need the amount of compute that you would normally have for a 100 billion to trillion parameter model. Some of the work needs to be, a little bit of fine tuning needs to be done when it comes to the prompt engineering, right? Not some of the prompts that we had before weren't producing exactly the same output that we had with the previous workflow. So we had to do a little bit of prompt engineering to get a similar response. So that took a little bit of time. But otherwise, once we were able to tune the prompts and we compared each of the previous outputs to our new OPEA output, they were essentially synonymous. They contained all the same pertinent information. Again, utilizing optimized frameworks. So in the back end, we were doing it on a 4th gen Intel Xeon. And since the model was quantized in INT8, we were able to take advantage of AMX. So we were still getting some of that same speed that you would get if you were doing API calls. The performance was still there even on a CPU-only instance. So being able to use optimized frameworks, quantizing your model, making use of that built-in instruction set will really help accelerate your workflow and ensure that your responses come back in a quick manner, right, for your customers. And then as I spoke to it before, the most difficult part was re-embedding the data into the vector DB. I think the vector size of the previous embedding model was 1536, and then the new vector size was 1024. And so when you're doing your mathematical comparisons for the question that you ask and the vector you have in the back end, they need to match when you're doing those comparisons, right? So if you've got a very large corpus of data that you need to that you're using for your RAG workflow, taking your new embedding model and re-vectorizing that data and turning it into and repopulating your vector DB could take a little bit of time. But again, once that portion is complete and those vectors are stored in your vector DB, you can reuse your existing retrieval workflows, and it'll work seamlessly to get that context that's needed from that vector DB. And so we started with this customer, and our team is continuing to work with new customers to implement something similar. I think that as we start to get more and more comparable, smaller instruct language models, we can even start moving some of these workflows from data center CPUs to our client compute. So the next step for us is to really start examining ways that we can take some of the 1 and 3 billion parameter models that are out there that have these large context windows that are appropriate for RAG, and finding ways that we can create that same workflow that we traditionally did in the data center, and now getting it ported over to the client. And so this was a great run for our team to sort of build this out, and we're looking forward to seeing how we can do this with more customers in the future. So it's a great experience. And that's it for what Chris and I have to present. Happy to take any questions or dive a little bit deeper into exactly how we made some of the changes, how long things took. So it's an open field. Please ask away.
A multi-layered question from someone on LinkedIn that I think is more generally about OPEA that I have to research, which I put in the chat. And if you should be able to see it, by the way, on StreamYard, the questions under comments, just if that's helpful. But so if you have answers to any of those things, feel free. But I think what is more focused for you is we have a question from LinkedIn. What other relevant OPEA components that the customer may consider using in the future, like fine-tuning services, guardrails? So what could they add on?
Let's see. So let me try to pull up our GitHub page to sort of show you all the different components that we have in OPEA. Give me just a moment. And this will probably be good for the group to sort of also see what we have. I will present. Okay. Share screen. Share screen. Hold on. Give me just a moment. Apologies, I have a lot of tabs open. Just have to find the right one. Okay, here. And share. Okay. Can everyone see the screen here?
Yeah.
Okay. So in this particular example, what we did here was we focused on just embeddings and just text generation. But OPEA has more than that, right? And so when you take a look into the, oops, wrong page here. So when you take a look at the microservices that we offer, and again, these are the microservices, you can think of them as these modular building blocks for RAG, right? So we focused on embeddings and text generation, but if you'd like to use a microservice that's just focused on retrieving, you can do that, right? If you want just if you want a microservice that focuses on data prep, we have that too. And so these different one that's maybe focused on audio speech, these particular components you can utilize for your particular workflow. Now, when it comes to the question, which was fine tuning, so when you're so I think what's great about RAG is that when you're passing in a contextualized prompt, you don't necessarily need to fine tune the model in that sense, where we're using a completely off the shelf model from Hugging Face. We don't do any fine tuning on that. What fine tuning we did do was really with the prompt templates, and that's a lot of that is really trial and error. With what Chris and I worked diligently with their engineering team to take a look at the different prompt templates, take a look at the outputs to see how we could improve them. So in terms of that fine tuning, we kind of have to do that. Like face to face and really assessing the outputs. When it comes to guardrails, you can host a guardrail model. I haven't done it personally, but as I understand, we can put up a guardrail model that essentially acts as an endpoint that you can then push your queries to evaluate whether or not that query is appropriate. And so that's one of the ways that you could use guardrail models in the same way that you stand up that endpoint to evaluate the query. You just pass in that query to that guardrail model. It'll evaluate it and then determine whether or not you should go forward with that query.
Cool. Let me see. I might have a question here for you. Well, so tell me. I asked this of Pramod too. Like, and you talked a little bit about this and what you learned, but like, was there anything that you found particularly challenging or interesting about OPEA? Oh, wait a minute. Haytham's back. Hey, Haytham, we're gonna go with Haytham's question. And you can see here, it's for fine tuning. Can a method like InstructLab, which I know we've talked about before, can be leveraged and offered as a feature? I think yes, maybe in the future, but go ahead. I'm going to let you take a look at that.
I am personally not that familiar with InstructLab, so I'm not sure, but I know our partner list is expanding very quickly. So
yeah, so I believe that comes from Red Hat, or Red Hat's involved in some way, and we have Red Hat is involved with the project. So if it isn't now, it is something I'll be mentioning. So I think that it has been mentioned in passing. So we'll definitely find that out. But thank you, Haytham. Oh, I was just going to ask, like, what did you find, like, what was particularly challenging or surprisingly easy with the PIA? Like, tell me a little bit about, because you're, what I really was excited about to have both of you guys talk was that this was like real. Do you know what I mean? Like, here was someone or a company with a solution. They went with, OpenAI, and then saw that there would be a difference. Just tell me a little bit about sort of like the journey.
Yeah, I guess I can start it off. I feel that when we're talking about challenges, there's probably just one that can come in, like that comes at the top of my mind is so when it comes to support for OPEA, when we've had to, I guess, when we've needed help, it has been a bit hard in the sense that we would have to just suggest changes on the GitHub itself. And so And yeah, and I feel that
Well, the good news is that's something I can help with.
uh-huh.
So yeah, I mean, like I said, there's like tens and tens. I don't know if we're up in the hundreds, but people working on stuff. And
Mhm.
so I agree, open source projects, it takes more than a village. And so I think that's why I talk about like documentation and stuff. And I'll talk to you guys about this after about, how can we incorporate this, if we haven't already, into the repos, make a blog post, stuff like that. Like I think we're kind of like at that point with the project where, okay, we've got like a critical mass now. We have to make sure it's documented and that there is support and that the more that people use it and adopt it, things are going to be uncovered and changes and tweaks are going to need to be made. And so, I think that that's just part of like the growing pains. But I also think it points to, I don't know, I guess the challenges of open source because, it takes like, people have to make time for it, but also what's great about it, right? So we can talk about this offline too, but like, if we can pinpoint what the issue is, it's something that, we can rally the working groups around, we can bring it up for, why, with the TSC and stuff like that. So any feedback like that from, you guys or anyone listening or watching, super helpful, right? Because it's really about enabling developers and companies. And this is something I was going to ask too. So LinkedIn user, why did the customer choose to migrate to OPEA? Can you talk a little bit about that?
Yeah, sure. I can touch upon that. So I think the key motivation for them was one, it was, yes, cost, right? So
Okay.
doing the evaluation for those queries you're paying per token, knowing how many queries and how many users would eventually use it, they thought to themselves, okay, this can get expensive very quickly. The second motivation was they wanted to make sure that the environment that they had was private. And the reason being is that when you contextualize these prompts with proprietary data, you want to make sure you know where it's going, right?
Mhm.
So it was a worry for them in the previous workflow where they said, is our data going to be retrained on? Do we know who's looking at it? Those questions kind of came up, and they came to the determination that we felt more comfortable knowing that we have control over the model that we have and the entire pipeline for RAG, all the way from the vector database to the model that we're eventually putting that contextualized prompt to. And I think I can touch upon that previous question as well. What was really great about it is, as we started to implement those changes, was just how easy of a drop in replacement it became. And as engineers, I'm sure we all know, when you change one thing, the whole system breaks, right? But because the endpoints are compatible with the previous workflow that they had, the code migrations were pretty seamless. And I think, Chris can speak for himself, but when I saw how easy it was to just drop in that replacement and use the exact same workflows, I was kind of astonished because, projects I've worked on before, making that change can be such a gargantuan task that having a replacement that worked pretty seamlessly, that used totally different workflows than prior, was really surprising to me, and one of the reasons why I think that customers would continue to be impressed or continue to want to use something like OPEA.
Cool. I wanted to follow up on so this customer was particularly interested in sort of like data privacy. And we've talked about like reasons people have, want to, are having trouble with GenAI. Does privacy come up a lot, and sort of like, and is the answer to that feeling more comfortable, being able to get in there and knowing more? Like, is that more of the build versus the buy sort of thing? Like, I don't know. Like, can you talk a little bit more about that?
Yeah, I think it depends a lot on the customer use case, but we're seeing that a lot, right? It's okay when there's so many different, when you're dealing with proprietary data, or whether you're dealing with data that maybe has some human context, medical data, all this high high value data that that's highly regulated, you're going to want to make sure that your workflow is private. And a big motivation for that was making sure that they knew that when they sent that contextualized prompt off to somewhere, they knew where it was going, right? They knew that, hey, this model is hosted on our instance that we stood up, that we know is private on AWS. And, they know all these things about where that contextualized prompt is going, which makes them feel a little bit more comfortable with making sure that they can get those actionable insights from data that they don't want anyone else to have.
Interesting. There's so many different aspects to it that are very interesting. Okay, we'll have one more question. It's from Hatham. And he says, on the data extraction preparation side, how the flow deals with complex formatted files. In particular, a painful one for him has been PDF files with complex merged rows table. What's the flow you like? Talk about the flow underneath.
Got it. So what was nice was that the customer already had built-in functions to ingest their PDF and HTML data. And I think what made that particularly easy was that it was only those two formats, right? And they had a lot of control over how those PDFs and how those HTML files look like, because it was their own self-published data. The point that you make is really interesting, right? As you start to get more complex data that you need to store in your vector DB that has images and charts, how do you take care of that? And I think that we need to start to take a look at new, workflows where when customers don't have those functions already to do the ingest portion, how can we build it for them? How can we make it easy for them? So I think that that's the next step. And Hatham, you make up a good point. We were lucky that this particular customer already had that built out for them. But I think building those functions for the OPEA would be a great next step.
Cool. Amazing. Well, I thank you both so much for taking the time. It takes time to do what you did, put the slides together, come here and present it. So I thank you both very much, and I will be in touch later. See what we can do next.
Thank you, and reach out to our team. We're happy to help with you guys with OPEA or with anything on AI.
Awesome. Sounds great. Thanks again.
Thanks, everyone.
Okay, so for our final presentation, I am going to take the wheel, although I am certainly the messenger here in terms of what we're going to present. This was, I was helped a lot by a bunch of people. Let me work on bringing up, so this is going to be about GraphRag. Let me share my screen and find out where we're going. Here we go. Okay, slideshow. Okay, so big shout out to Andreas from Neo4j and my colleagues Rita and Teresa from Intel. So we won't take a super amount of time to go through all of this since we have earlier in the event. GenAI, complex but worth it. Lots of issues with implementing it. There is difficult. There's cost, and that's an interesting one with GraphRag that you need to think through. Is it worth the cost? Because it is a bit more money because of the way it is implemented. There is so much AI goodness out there. There's not enough people to make it happen. Once you have something in order, you need to think about like the governance, need to think about data availability. So there's many implementation barriers that are out there. So when OPEA came together, RAG is sort of the way that people are really excited about and doing generative AI, right? And so, as we've talked about, it is a way to access your company's knowledge, right? A way to do this is the way that RAG does this is it takes that knowledge base, but it also anchors it in other trusted knowledge bases, right? And make sure that you're getting a good answer. And so what I've seen here is that sort of like a standard way to do this is through vector DBs. And we have a bunch of those that are viable within OPEA. Like I've seen Redis is built out, Quadrant is built out. I think Milvis is in there, but there's a number of them, right? And so this has become a way of dealing with the hallucinations that happen, of making sure that you're getting quality answers, right? Because we've talked about, like, if an LLM is going out and listening to another LLM, and it can start to warp the answer, right? So this kind of like makes it so that is like a cornerstone, and gives you the right answer. So OPEA, which you all know and love at this point, I hope. So this is something else we've talked about too, that we have all of those different blueprints that I've shown, that we have and it was interesting to hear from Joshua about people wanting to be able to like root around, I think, and understand how something works. And so what's great about OPEA is that it has this framework of these composable building blocks, and you can understand what steps your data and the model are going through, and where your data is and the kind of answers that you're getting back. So it was interesting to me that, and this might not be true of everyone, like you said, like it could be for medical or insurance or finance, but this idea that you may want to be more hands-on with this workflow, and that's really interesting. And OPEA provides you a way to, I think, get the right level of insight throughout that workflow. So that's great. We also had Pramod brought us through this idea that it is composable building blocks or microservices. Like we have the retrievers and the re-ranking and the guardrails, right? And so it's really like puzzle pieces being put together, and that creates a bigger, what we're calling a mega service, and that there is an easy entry point, right, for the requests and APIs and stuff like that. So, as amazing as RAG workflows are, and they are amazing for a number of reasons, when things are more global, when questions are more global in nature, and you need something more comprehensive, a knowledge graph in addition to vectors is sometimes called for. It can be additive to a RAG workflow. And on the right here, this is from Neo4j's Graph RAG Manifesto, which is super interesting if you haven't read it. I thought it did a really good job of sort of breaking things down. So this gives you an idea, right? And so with the Graph RAG, it's good about my understanding, and everybody chat amongst themselves if they have different ideas, is that RAG is good about going in and pulling out an answer, right? And a good answer. Graph RAG helps with pulling the answers from different places and stitching them together. And it integrates those pieces to give you a more robust answer. So the thing that kept coming up was like these global questions, right? So it isn't necessarily simple in nature where you can just pull it. It's something that it needs to be built, and the understanding of how data is connected to other data, right, within your database, and having things in graph form where those connections are shown, that's going to give you, for these global, more complex questions, better answers, or answers at all that regular RAG might not happen. And what's interesting I found out too is that, and this is where sometimes cost can come in, is that, and they might say this in the demos when I showcase them, but it's not a one-time like to the LLM. It has to go multiple times. So this first one, and again, I'll make all the slides available, and you can go to this actual PR, which is not merged yet, but this is from our friends at Neo4j, and it's a multi-agent system. And so I wanted just to pull this out so that you can see what it's doing. And so I'm not going to go through this because I actually have a video that is going to go through it, and much better than I could do it. But it's really cool to see it in action. So this is, let's see if I can get this all to work correctly. Fingers crossed. I'm going to try and blow it up.
I'm so excited to be working with OPEA, collaborating together to bring knowledge graphs and GraphRag into their fantastic microservices architecture for production-ready GenAI applications. The example that we're working on is, of course, a GraphRag example. Let me walk through the workflow so you know what's going on here. We've got, of course, user input. And because this is an agent-based, workflow that we have here, the user input's can go to a React agent. That's the, reasoning and then acting agent supervisor itself. That's going to interact with an LLM service, a microservice that, is the fronting of the LLM to figure out, okay, given this user input and these tools that are available, which tool should I use to try to, get an answer for the user here? We provided two tools in this initial example. One focused on unstructured data that uses a combination of vector search with pattern matching, and the other that does structured data queries. Of course, this is a text-to-cipher based tool. The unstructured data tool makes use of an embedding microservice, then also talks directly to the knowledge graph microservice. The structured data tool reaches out to the LLM to generate a query for the user's input, runs that cipher query against the knowledge graph microservice. That's the overall flow. Let's take a look at what this is like in action. Of course, the data set that we're using here is my favorite. It's the Edgar data set. This is the SEC financial filings, in the United States. So we have financial filings from publicly traded companies and also the investors in those companies. So we can ask questions like, what companies are in California? Are in California. And this is an agent-based approach, of course. So you can see that the first thing that happened there in the tool selection was the agent's like, okay, given the question that was being asked, let's scroll back up here. It decided, okay, I can use the GraphCipher QA chain to query about the location of companies in California. So that's the action that it took. And here's the cipher query that was generated by the LLM. It does a match for a company that's located at some address, where that address, the state, is California, and then just return those. Given all that and the data set that we have, it's a small data set. Here's what it came up with. So a couple of companies that we know are in California. Let's ask a little bit more about NetApp. So we know we have financial filings here. So what is NetApp's primary business? That's one of the things they'll have to state in their filings with the SEC. Okay, here it's decided to use the company retriever tool. So different this is the first tool that actually does a combination of vector search and then pattern matching. So instead of the text to cipher tool that was used the first time around. And it got information back from the filings, from the unstructured data, and then used that for producing a final result. Fantastic. Okay, let's ask it a little bit more tricky question. Something that we know is not in the unstructured data that you can only answer if you have a combination of unstructured and structured data. So tell me about what NetApp's investors. So what are NetApp's investors? I'll spell that correctly and I'll say who are. I'll try to help the LLM out with some proper English. Okay, again, it uses the company retriever tool. And the thought, of course, here was it realized that the retrieval tool is able to find information about investors in addition to companies. And so that's what it called out to. And it found out the information that it needed. And here's the investors in some interestingly formatted text. Well done for the LLM there. Okay, we'll go a little bit deeper here. We'll ask, some questions about, what are the risks to companies? So not about a particular company, but, which companies are at risk to something. So let's say what companies are at risk from a chip shortage. And that's going to go ahead and run. And hopefully it'll select the same company tool. Or perhaps it'll just take a little nap. There it goes. Okay. So it often used the company retriever tool. So here's the thought that it had. It needs to find information about companies. It knows it can use the company retriever tool for that. Perfect. It does the query for that, which ends up being a vector similarity search to find, that some companies will have talked about what their risks are. And so we found Western Digital. Oh, and also Palo Alto Networks. Okay, great. Now we'll do the same thing again. Can we combine this, query about risk all the way to the investors? Let's try that. So what, not companies, but what investors are exposed to a chip shortage? Okay, let's take a look at the reasoning here for a second. So to answer this question, find companies affected by the chip shortage and then identify their investors. Great. So it's going to start by identifying companies affected by a chip shortage by using the company retriever tool. That's good. Curious that it found Nike Incorporated. I think it's probably mistaken on that one. But Western Digital, okay, yeah, that's completely right. And then it said its final answer are based on investments into Nike and Western Digital. Here's the investors in that. Now, it got Nike wrong, so we need to have an extra little challenge in there to make sure that when it finds companies that are at risk, say, hey, are you sure? Is this company actually at risk from a chip shortage? I don't think that's really affecting Nike's shoe business. But okay, we'll give it a pass on that for now. This is some more improvements we can do to the prompt engineering. But the overall flow made sense, and actually the tool use made sense. And more importantly, all this is actually designed to take advantage of all the microservices that you have within OPEA. So this is production ready. Once you've got all of the different guardrails in place, this is something that can scale completely for production. Hope you enjoyed that. Thanks.
Awesome. So that was cool. Let me get this back to where I need to.
I'm so excited to be working with
Here we
OPEA.
go. Okay. I want to get back to slideshow. There we go. Okay. So this next one is, so Microsoft came out with a paper on a graph RAG approach, which is somewhat different than that, right? And so we're going to take a look at this. This is, I believe, merged in the project already. And we have a short video here that doesn't have any voiceover. So I'm just going to chime in at a couple of points just to give a little bit of guidance. All right. So basically, we're going to start by uploading the data and taking a look at it. So the next step that you're going to see in a couple of seconds is that it's going to be connected to the Neo4j database endpoint. And we're going to look at the extracted graph from the pre-processing step. And then we're going to just put a question in here. And then I think it takes just a little bit and we'll get an answer. I think about 10 more seconds. So cool, right? So that is up and running right now. So you can go and check that out. Nope, I don't want to see that again. Just showcasing our partners. It's great to be, having this great group of companies, and I really look forward to working with them more and more. You can see when we do, really cool stuff happen. So big shout out to Neo4j. And then again, of course, we want you to participate. Hatham, I'm looking at you if you're still here. So let me stop sharing. And there might be questions here that I can't answer, but I'm going to look at them anyways. There's maybe, this is interesting from Petter. There is maybe different policy regulation for us in Norway and Europe compared to US. How will that reflect on the development of OPEA? So that's super interesting. The companies that are involved are global companies. So we do have people from all over the world working on this. And, as far as I know, we're following sort of pretty standard procedure with open sourcing the project. It's part of the Linux Foundation, which again is a global entity. The license is Apache 2.0. I think implementing projects with OPEA and other software is where you're going to find maybe there's different regulations. So I don't think it's OPEA per se, but I mean, that's really interesting and would love to have that, sort of discussed. And if anything does need to be done, we could get on that right away. I haven't seen it yet. But we're following, we're working closely with the Linux Foundation and we have lots of, bright stars in the open source community that are working on this project. So I don't think that we'll have any trouble with that. But it is interesting because it does, there are shifts from, different geographic regions. So thank you for that question. I'm now interested in finding out more about that. All right. Okay, thank you for that question. So just to wrap up, thanks to everyone. Keep an eye out for the 1.1 release, which is, I believe, next Friday. So for those in the US, when you're just, on the couch, having eaten too much turkey, check it out. What else are you going to do since you can't move? And we've got a great 2025 ahead of us. This is the last virtual event for this year, but we'll be filling up December with some blog posts and we'll still be active on social media. And then we'll see everyone with some new events in the new year. And like I said, I just want to hear and present more and more from all of the different partners and how they're using it. We'll get people, like I said, the contributors and the users, and things are all looking great for OPEA. And I appreciate all of your help and all of your interest. And I hope to see you again soon.